Hello everybody, this is Mr. Koops, and here is our tutorial on the circle segments theorems. Okay, I'm making this because Leslie needed the lesson because she couldn't see everything today, so here you go, Leslie. All right, so the first theorem says that when we have two chords that intersect inside the circle, that they make two segments. So this makes segment DE and EC, and then this one makes segment AE and EB. And when we multiply these two segments together, AE and EB, it is equal to EC times DE. Okay, so this segment times this segment is the same as this segment times this segment. Okay, so a problem would look something like this. We would take this segment, MN, which is x plus 2, and we would go x plus 2 times the other part of that segment, which is this one down here, x plus 1. And then we would set that equal to x, which is this down here, times x plus 4. So x times x plus 4. Okay, now after some distributive property and foiling here, we would get x squared plus 3x plus 2 equals x squared plus 4x. Okay, now this is x times x makes x squared, x times 4 makes 4x, and then we would have x times x is x squared, 2 times x is 2x, and then x times 1 is 1x, so 2x and 1x makes 3x, and then 2 times 1 is 2. So that is how we would get this, okay? Then we just solve the algebra. We subtract x squared from both sides to cancel that, so that cancels, and then we're going to subtract 3x from this side. That cancels, and we get 2 equals x. Now that we know x equals 2, we can answer the question that says find ML and JK. I trust that you can just plug those into MN and NL and KN and NJ to find that. But that is how we would find the value of x right there. Okay, so that's the first problem here. Okay, so the second problem here. So this is what Sanaya actually caught me on today. Sanaya caught me and corrected me on this. So what this says is that when we have two secants are segments or lines that go inside and outside the circle. Okay, when we have two secants that meet at a common point outside, we take the circle, we look at the circle, and the circle kind of breaks each secant into two different segments. Okay, now what we have here is that this short segment multiplied by the entire secant segment is going to be equal to this short segment times this entire secant segment. Okay, so the red times the red plus the black equals the red times the red plus the black over here. Okay, so let's take a look at how that works. So going on example 3 here, we've got 6 times 9 plus 6 over down there on that example. This is this example right down over here. So we have 6, which is the outside part, times 9 plus 6, which is 15. That's going to be equal to 5 times x plus 5. Okay, so 6 times 15, let's go ahead and get our calculators out so we don't make any mistakes there. 6 times 15 is going to give us 90. So we have 90 equals 5x plus 5 times 5 is 25. Okay, so now we subtract 25, we subtract 25, that cancels, and then we get 90 minus 25, 65 equals 5x, we divide by 5, and we get that x equals 13 for this one. Okay, now let's take a look at number 4 here. Lord have mercy. Okay. Okay, now looking at example 4 down here, we've got 3, we're going to take that outside part, 3 times 3 plus x plus 2. Okay, again, this is the outside piece times the sum of the outside piece and the inside piece is equal to x plus 1, which is the outside piece, times the sum of the outside and inside piece. So over here we would have x plus x, which is 2x. And then over here we would have plus 1 and minus 1, which is 0. So we would just have this. Okay, now we distribute and solve. So actually, we could simplify over here a little bit. So we've got 3 times 3 plus 2 is 5 plus x equals x plus 1 times 2x. Okay, so 3 times 5 is 15 plus 3 times x is 3x equals x times 2x is 2x squared, and then 2x times 1 is 2x. Okay, so now what we have to do is we have to get all this stuff on the same side and solve a quadratic equation. Okay, and we can do that by factoring or using the quadratic equation, or the quadratic the quadratic equation. So we've got this piece over here. I'm going to move this negative. I'm going to subtract 3x. That cancels, and we get 15 equals 2x squared minus x. And then I'm going to subtract 15 over here, 15 over here. That cancels, and we get 0 equals 2x squared minus x minus 15. Yeah. Okay. Oh, wait a minute. No. All right, sorry, folks. My my contact was kind of bugging me, so I just needed to make sure that everything was working out here. Okay, so got this now. So we were at this point. We have 2x squared minus x equals negative 15. So now we need to factor this out. Okay. Now I'm not sure if you learned this kind of factoring a binomial with a leading coefficient, but I remember when I was in 8th grade and we were doing this. This was always tough. Like, we could handle this, no problem. But as soon as you put a number in front, forget about it. That's a more difficult problem. Now, when I got to college, I learned this trick that actually I read a math book once, and I learned this trick that if you multiply the first number in your trinomial and your last number, so 2 times negative 15, that gives you negative 30. Okay? And then you take this number in the middle, negative 1, and that gives you your combination there. Okay? We have to find two numbers that multiply to make negative 30 and add to make negative 6. And we get that if we use negative 6 and positive 5. Negative 6 times 5 is 30. Negative 30, I'm sorry. Negative 6 plus 5 is negative 1. So now we're going to take this and we're going to use this to kind of make an equivalent expression that we can factor by parts, I believe it's called. So we've got 2x squared, okay, minus 6x, minus 6x plus 5x minus 15. Okay, so now what we've got here, if you notice, this is the exact same equation here. Okay, we've just sort of decomposed it into two different parts here. So we've got, if we combine this, then we get the same thing here. So this is the same equation. So now what we're going to do is called factoring by parts, which means we're going to kind of split the equation sort of like this, and then we're going to factor. Out of this, we can pull a 2x, because you pull a 2x out of there, you're left with an x. You pull a 2x out of here, you're left with a minus 3. Okay, and out here we take out a 5. So if we take out a 5 here, that's going to leave us with an x minus 3. Okay, so now we've got this x minus 3, which is a common term that we can pull out as well. Okay, so we pull out the x minus 3, and that leaves us with 2x plus 5. And now we've successfully factored that. Okay, now if this is set equal to 0, then that leaves us with two options. We set x minus 3 equal to 0, and then we do the algebra there. So one option is that x equals 3. Okay, that's a nice option. It looks like it'll fit. But let's take a look at the other option. If we set this equal to 0, 2x plus 5, I forget what property that is, but it's a property that says if this is equal to 0, since the equation is equal to 0, if this is equal to 0, that's one possible solution. And if this is equal to 0, then that's one possible solution as well. So we do that. We subtract 5, cancel. 2x equals negative 5, divide by 2. And then we get our other possibility for x is equal to negative 5 over 2. So these are our two possible values for x. Okay. Now, one of these answers is correct, and one of them is bogus. It's just mathematical hogwash. It's we call that an extraneous solution. So now we got to figure out which one is the real and which one is the fake. Okay. So if we go back to our problem, let's kind of think about the context of what we're looking at here, okay? So if we look at our problem, we're actually looking, oh, that's not helping us. If we look at our problem here, we're actually looking at the length of a segment, okay? Now, one thing we know about length is that length cannot be negative at all. You can't say this is negative 5 feet long. That just doesn't make sense, okay? So we know our answer does have to be positive. Now, if we mentally plug in 3 plus 2 is 5, so that could be possible. 3 plus 1 is 3, that could be possible. 3 minus 1 is positive 2, so 3 actually works for everything. If we try to plug in negative 5 over 2 or negative 2.5, right here at this one, so negative 2.5 minus another foot, that would give us negative 3.5 feet. We can't say that the segment's negative 3 feet. What does negative 3 feet look like? You tell me something that's negative 3 feet long, okay? And you're just not going to find something because that's not how we don't measure with negative values. So since this will cause a negative length, this is our extraneous solution, and our solution is right here, x equals 3, okay? All right, so now we've got this last theorem, and I'm just going to hop to, I mean, you can try these two for your own practice. I believe the answer to this one is 2. The answer to this one is like 4.8, I think. So if you're trying this on your own, you can try applying this theorem. The answer to number 5, I believe it's 2. And the answer to number 6, I believe, is 4.8. So you can check that yourself. But I'm going to do number 7 because that's the tricky one. So I'll help you out with that one. Okay, so what this theorem says is that if we take EA, this tangent segment here, and we square it, that is going to be equal to the short red segment, again, times the entire segment, okay? So let's take a look at what we've got there. For number 7, the short segment is going to be 144, okay? It's going to be 12 squared, which is 144. Actually, let me just set that up for you. So using the theorem, it would be 12 squared equals, the short segment here on number 7 is x, and then the long segment is going to be x plus 10. Okay, so 12 squared is going to be 144 equals x times x is going to be x squared, and then x times 10 is going to be 10x. Okay, now to solve this, we have to put it in quadratic form. So we subtract 144, we subtract 144, cancel, and then we get 0 equals x squared plus 10x minus 144. Okay, and then we have to do our factoring again. Okay, so we do our factor x, and then we have our product down here. Whatever we get, it needs to multiply to make 144, and it needs to add up to 10. Well, fortunately, since we've done this before today, we know that that's going to be 18 and negative 8. 8 times 18 is 144. And then 18 minus 8 is going to be 10 here. So we can go ahead and, since we don't have a leading coefficient here, we don't have to do the partial fraction decomposition. We don't have to do the partial decomposition. So we can actually just look at this as our solutions here. We have x plus 18 and x minus 8 equals 0. Okay, now if we take each of these and set them equal to 0, we're going to find out that we can either have x equal to negative 18, or we can have x equal to 8. Either one of those situations needs to fit our situation here. And fortunately, we can just take a look at this and say, hey, we need one of our lengths to be x, okay? Well, we can't have a length of negative 18 feet, so that's no good. This is our extraneous, I'll type it out, I'll write it out this time. This is our extraneous solution, okay? So our final solution here then is x equals 8, okay? And then really quick before you go, I'm gonna check these two answers over here just to make sure you can practice that and get your feedback. Yeah, you can go ahead and do this as well. So yeah, 5 is going to be 2 and 6 is going to be 4.8. Good luck with that, and hope this helps you out. Thank you very much. Have a great day.